This is the solution video for question 11 from paper 2 of the 2019 TMUA or CTMUA exam. In this question we're asked to consider an arithmetic series with n terms, all of which are integers. We're told that the sum of this arithmetic series is 20, and then given all this we're asked which of the following must be true. So statement 1, the first term of the series is even. Statement 2, n is even. Or statement 3, the common difference is even. And we're given various sets of 1, 2 and 3 that might be true, from none of them being true to all 3 of them being true. So let's go through statements 1, 2 and 3 one by one and determine if they're true or false. So let's look at 1. So proving 1 looks a bit awkward. So the first thing we do is we try and find some counter examples. We try some examples, see if this generally holds, and then we'll have a go at proving it if we can. And we quite quickly see that the first term of the series is even. Well, if we've got a series of 2, if we can just find 2 odd numbers to add together to make 20, we've got a counter example. So one counter example is 1 and 19, because 1 plus 19 is 20, and any pair of numbers will produce, albeit a very small arithmetic series. And you could use loads of counter examples here: 3, 17, 5, 15, etc. So 1 is false, or 1 need not be true. So let's look at 2. So 2, n is even. Well, we could make a proper effort trying to prove this, but immediately we see that this has a major problem, is that it's got a counter example which is just 20 on its own, because this one term, it is an arithmetic series, but n isn't even because n's 1, and certainly the sum of this series is 20. You might legitimately feel that this is a little bit cheating the system in a way, so there is another more genuine counter example of 2, 3, 4, 5, 6. But this would be completely fine for noting that 2 doesn't have to follow from the sum of the series being 20. Now 3, you may have immediately spotted that this isn't true, because this is a counter example to this as well. But that's quite, if we haven't spotted this, it's quite difficult to come up with a counter example to this. So you begin to think it's true, but it's not in fact, because there's a small trick you can use. So if we think, just take the series 0. So that has a sum of 0. Minus 1, 0, 1, because we're allowed integers, so minus 1's fine to put in our series. So minus 1, 0, 1, sum 0. So this has an odd common difference, has a common difference of 1. Minus 2, minus 1, 0, 1, 2. Sum of 0, and you can probably see where this is going, because if we carried this on and then just added the number after here, so we had a 3 here, minus 2, minus 1, 0, 1, 2, 3, we'd have a sum of 3. And so if we use this, minus 19, minus 18, dot dot dot, to 0 and then up to 19, we know the sum from here to here is 0, and we just add the 20 we want. So we've got an arithmetic series, common difference 1, so the common difference is odd, but the sum is 20. And so 3 isn't true either. And so we've got counter examples to 1, 2 and 3, and so that matches option A in our answers, and so our answer is A.